What if you had a secret passenger living inside you, a microscopic stowaway that most of us pick up at some point in our lives, often without even knowing it? This is a biological reality for the vast majority of the global population. The passenger is a virus called the Epstein-Barr Virus, or EBV. This tiny organism belongs to the herpes virus family, known for lifelong infections. By adulthood, an estimated 95% of us carry EBV. The initial infection often happens in early childhood or during the teenage years, causing infectious mononucleosis. The virus never truly leaves, it retreats. It finds a safe harbor inside some of our immune cells, specifically a type of white blood cell called a B lymphocyte. There, it enters a dormant state. For most people, this hidden presence causes no further trouble, but this quiet coexistence is a delicate balance, one that can be disrupted. It is a master of hiding in plain sight. What if its quiet presence carries a hidden, long-term risk that we are only just beginning to comprehend fully? Scientists have long known that EBV wasn't entirely benign. The International Agency for Research on Cancer classified it as a Group 1 carcinogen back in 1997, putting it in the same high-risk category as tobacco smoke and asbestos, based on links to rare cancers like Burkitt's lymphoma. Now, a new study reveals a more alarming connection. Following over 74,000 adults, the study found that specific EBV antibodies could signal a dramatically increased risk for cancers like lymphoma, liver, and lung cancer. For nasopharyngeal carcinoma, the risk was 26 times higher. The leading theory suggests the virus hijacks our cellular machinery, damaging DNA and causing mutations that accumulate, potentially leading to uncontrolled cell growth and cancer. The Epstein-Barr virus is a master of transmission, allowing it to become one of the most successful human viruses. Its primary mode of transport is through saliva, earning it the nickname the kissing disease. Close contact is a key factor, particularly among teenagers and young adults. Sharing a drinking glass or using the same toothbrush can spread the virus. This explains why most of us encounter EBV so early in life, often during childhood. At this young age, the immune system often deals with the virus swiftly, resulting in either no symptoms at all or a very mild illness. When the first encounter with EBV is delayed until adolescence or young adulthood, the classic symptoms of infectious mononucleosis, or mono, are most likely to appear. The body's powerful fight against the virus causes extreme fatigue, a persistent high fever, a severely sore throat, and noticeably swollen lymph nodes in the neck. Once infected with the Epstein-Barr virus, you carry it for life. EBV has evolved a sophisticated mechanism to evade our immune defenses and establish a permanent residency within our cells. How does the Epstein-Barr virus persist for life? It hides. EBV targets B lymphocytes. By invading cells designed to protect us, EBV hides from the body's defenses. Inside a B cell, the virus becomes dormant. The virus switches off most of its active genes, inserting its DNA into the B cell's nucleus. This creates a lifelong reservoir of the virus. The immune system controls the infection but can't eradicate the hidden viruses, establishing a delicate equilibrium. This latency is common among herpes viruses. This truce relies on the continuous vigilance of our immune system. If that guard is lowered, the virus can awaken. If you're enjoying this video, don't forget to like, share it, subscribe, and click the notification bell so you do not miss any of our future videos. Thank you. The delicate balance between the dormant Epstein-Barr virus and our immune system can be disrupted. When the immune system's surveillance weakens, even temporarily, the virus can seize the opportunity to reactivate. During reactivation, the virus switches from its latent sleeping state back to its active lytic phase. It begins to produce new viral particles, effectively rebooting the infection cycle. These new viruses can then infect other B cells, or they can be shed in saliva, allowing the virus to spread to new hosts. For most healthy people, these reactivation events are minor and quickly brought back under control by the immune system, often without the person ever noticing any symptoms. However, certain conditions and life events are known to be significant triggers for EBV reactivation. One of the most common triggers is psychological stress. Periods of intense, chronic stress, whether from work, relationships, or other life pressures, can produce hormones like cortisol that suppress immune function. This temporary weakening of our defenses can be just the opening the virus needs to awaken from its slumber. Similarly, significant physical stressors such as surgery, lack of sleep, or even extreme overtraining in athletes can have a similar effect. Essentially, any prolonged state that puts the body under significant strain can compromise the immune control that keeps EBV in check. Another major trigger for reactivation is a compromised immune system. This is most dramatically seen in individuals who are immunosuppressed for medical reasons, such as organ transplant recipients who must take drugs to prevent rejection, or patients undergoing chemotherapy for cancer. In these cases, the immune system is intentionally weakened, giving EBV a much freer rein. Furthermore, other infections can also play a role. There is growing evidence suggesting that infections like COVID-19 can disrupt immune function in a way that allows for the reactivation of latent viruses like EBV, potentially contributing to some of the long-term symptoms experienced by patients. This cycle of latency and reactivation is central to understanding the potential long-term risks associated with EBV. While a single reactivation event might be harmless, repeated episodes over many years could have a cumulative effect. Each time the virus becomes active, it manipulates the host cell's machinery to replicate itself. Scientists believe that this repeated interference, this constant hijacking of our cellular processes, increases the chances of something going wrong. It raises the probability of genetic errors and mutations occurring within the B cells, potentially nudging them down a dangerous path. This is the mechanism through which this invisible infection might eventually lead to the development of cancer. For years, scientists knew Epstein-Barr Virus, EBV, could cause rare cancers like Burkitt's lymphoma and nasopharyngeal carcinoma. In 1997, the IARC classified EBV as a definite carcinogen, alongside asbestos and tobacco. Most people, though, felt safe. EBV infects 95% of us, but only a few seemed at risk. That changed with a massive IARC study tracking over 74,000 adults in China for years. The study's results were a bombshell. EBV's cancer risk is much broader than anyone thought. Researchers found that certain antibody patterns against EBV meant a much higher risk for several cancers, not just rare ones. Suddenly, EBV wasn't just a silent passenger. It was a potential threat to billions. The question shifted from, can EBV cause cancer, to how many of us are at risk? This research forces us to rethink our relationship with this common virus. EBV, once seen as a minor nuisance, is now a possible long-term danger hiding in our immune cells. The IARC study didn't just add a footnote, it opened a new chapter in cancer research. The world must now pay urgent attention to the true scale of this invisible threat. The IARC study's breakthrough was focusing on specific antibodies, not just the virus itself. Researchers zeroed in on VCA-IgA, an antibody that signals frequent EBV reactivation in mucosal tissues. High levels of VCA-IgA in the blood were a red flag. For nasopharyngeal carcinoma, people with these antibodies were 26 times more likely to develop the disease. This suggests a simple blood test could identify those at highest risk. The findings are especially relevant in southern China, where this cancer is common. VCA-IgA acts as a warning flare, showing the immune system is fighting a constant battle with EBV. The real risk isn't just carrying the virus, but how your immune system interacts with it over time. Frequent reactivation, as shown by these antibodies, seems to set the stage for cancer. This shifts the focus from the virus's presence to the ongoing struggle between EBV and its host. It's a more nuanced view of how a lifelong infection can lead to devastating outcomes. Understanding these markers could revolutionize screening and prevention. The interplay between virus and immunity is now at the heart of EBV cancer research. The IARC study's headline was "The 26-fold risk for nasopharyngeal carcinoma," but the danger didn't stop there. EBV was linked to higher risks for several other cancers, including lymphoma, liver, and lung cancer. People with the high-risk antibody profile had a 3.2 times greater risk of lymphoma. EBV isn't just a bystander. It actively hijacks B cells, increasing the chance of cancerous mutations. The study also found a 1.7-fold increased risk for liver cancer and 1.76-fold for lung cancer. Even modest increases matter when these cancers are so common worldwide. The findings suggest EBV's reach extends far beyond what was previously known. Chronic inflammation or migration of infected cells may explain its impact on distant organs. Scientists are now urged to look for EBV's fingerprints in a wider range of cancers. EBV must be considered alongside other major cancer risks like smoking and alcohol. How does EBV turn from a common virus into a cancer threat? It's all about cellular sabotage. When EBV reactivates, it produces proteins that hijack B cells, controlling their growth and survival. This interference keeps cells alive longer and pushes them to divide, raising the risk of genetic mistakes. EBV's proteins also disrupt DNA repair, making mutations more likely and less likely to be fixed. Over years, these errors can accumulate, disabling tumor suppressor genes or activating oncogenes. The result, a perfect storm for cancer to develop. EBV acts as a long-term saboteur, quietly damaging our cells over decades. The IARC study's link between high antibody levels and cancer risk fits this model. Antibodies are a sign of ongoing viral reactivation and cellular stress. EBV doesn't cause cancer overnight. It's a slow, hidden process. This understanding is crucial for developing new prevention strategies. The battle between EBV and our cells is a silent, high-stakes war. Recognizing this process is key to stopping EBV-driven cancers. EBV is everywhere, but its cancer risk isn't the same worldwide. Nasopharyngeal carcinoma is rare in the West, but common in southern China and Southeast Asia. This suggests more than just infection is at play. Genes and environment matter. Certain genetic traits, more common in some populations, may make cells more vulnerable to EBV's effects. These genes can influence how the immune system responds, affecting viral reactivation. Diet also plays a role. High consumption of salt-cured fish and preserved foods introduces carcinogens like nitrosamines. The combination of EBV, genetic predisposition, and dietary carcinogens creates a perfect storm for cancer. That's why two people with EBV, one in London, one in Hong Kong, face very different risks. Understanding this interplay moves the focus beyond just the virus. Risk is shaped by a web of genes, environment, and lifestyle. This complex story is crucial for targeted prevention. Cancer risk, including from EBV, isn't distributed equally. Poverty amplifies vulnerability. Socioeconomic status shapes health outcomes, from access to care to nutrition. People in poverty often lack regular checkups, delaying cancer detection. Advanced screening, like EBV antibody tests, may be out of reach for many. Poor nutrition weakens the immune system, making EBV reactivation more likely. Diets low in fresh foods and high in processed ones deprive the body of vital nutrients. Over time, this increases the risk of viral reactivation and cellular damage. Chronic stress from financial insecurity further suppresses immunity, triggering EBV flare-ups. Living in poverty creates a biological environment where EBV can do more harm. The fight against EBV-related cancers must address these social inequalities. Health isn't just about biology, it's about the world we live in. Tackling poverty is key to reducing cancer risk for all. Ultimately, your risk from Epstein-Barr virus depends on the health of your immune system. For most of us, our immune systems act as a vigilant warden, keeping the virus dormant in our B cells. However, anything that weakens our immune defenses can disrupt this balance, allowing the virus to awaken. Immunocompromised individuals face a higher risk of EBV-related cancers. Modern life stresses can also compromise immune health. Emerging evidence suggests other viral infections can temporarily disrupt immune control. Maintaining a resilient immune system is crucial. Risk is dynamic, influenced by lifestyle, stress, and exposure to illnesses. Focus on strengthening your immune system to keep EBV in check. Given that nearly all of us carry the Epstein-Barr virus, the most powerful strategy for protection lies in strengthening our internal defenses. A robust immune system is our best line of defense. This begins with fundamental pillars of health, particularly nutrition. Your immune cells require a constant supply of high-quality fuel and materials to function optimally. This means focusing on a diet rich in a diverse range of nutrients that are scientifically proven to support immune function. Key among these nutrients are vitamin D and zinc. The health of your gut microbiome plays a critical role in your overall immune resilience. You can support your gut health by consuming foods rich in probiotics like yogurt, kefir, and sauerkraut. Ultimately, fortifying your immune system is an ongoing daily practice. By prioritizing a nutrient-dense diet packed with immune-supporting vitamins, minerals, and gut-friendly foods, you are actively strengthening your body's defense. Building your immune system and avoiding triggers that weaken it are crucial. Chronic stress is a potent immunosuppressant. Constant pressure causes excess cortisol production. High cortisol levels suppress immune cell activity, creating an opportunity for latent viruses like EBV to awaken. Managing stress is fundamental for viral defense. Implement stress management techniques like mindfulness or spending time in nature. Regular, moderate exercise reduces stress and stimulates immune cells. Sleep is also critical. It's when your body repairs and restores itself. During sleep, your immune system recharges and produces cytokines. Sleep deprivation weakens immune function and is linked to EBV reactivation. Prioritize 7 to 9 hours of quality sleep per night. Be mindful of lifestyle choices. Avoid extreme diets and excessive alcohol. Manage stress, prioritize sleep, and avoid weakening habits to minimize EBV reactivation. Empowering yourself with knowledge is critical in navigating EBV risks. Studies have identified antibody markers like VCA-IgA as indicators of higher risk, opening avenues for proactive health management. If you have risk factors like a family history or immunodeficiency, discuss EBV antibody screening with your doctor. Antibody tests provide valuable data. Low VCA-IgA levels can offer peace of mind. Elevated levels don't guarantee cancer but indicate a higher baseline risk. This motivates protective lifestyle strategies and vigilant health planning with your doctor, including regular checkups and symptom awareness. Stay informed about EBV research. The scientific community is intensely focused on this virus. Clinical trials are underway for preventative vaccines and new antiviral medications. By staying informed and supporting your immune system, you're taking control, moving towards empowered management of your long-term health. We began by unmasking the Epstein-Barr virus, an organism residing within most of us. It's not just the cause of mononucleosis, but a group 1 carcinogen. Groundbreaking research forces us to confront a new reality. This silent passenger may not be so benign. Specific antibodies can signal a shockingly high risk for cancers. Frequent reactivation can repeatedly hijack our cellular machinery, paving the way for malignancy. This shifts the narrative to active, long-term risk management. This is a call to action, handing the power back to us. If you got value from this video, please consider smashing the like button, share it, subscribe, and click the notification bell so you do not miss any of our future videos. Thank you. Fortify your immune system with nutrition, manage stress, prioritize sleep, and stay proactive with your doctor. This knowledge inspires vigilance, not panic. Take control, transforming into an empowered guardian of your well-being.